Right, this recording is to help you with the lesson on hyperbolas. So just like the lessons prior to this, we have kind of our formulas or equations at the very end of the lesson in this little chart setup here. Always copy these down in your notes so you can use them on every problem that you're working on, especially when we're talking about our conics here. Alright, so with a hyperbola is a little bit different. It almost looks like you have two parabolas back to back that are kind of like reflected of each other. So you can kind of notice the graph over here. This is what a hyperbola looks like. They can also open on the left and the right instead of up and down. Okay, so we are dealing with that type of graph in lesson 3 here. Okay. So if we need to find the center, vertices, foci, and asymptotes, if we know the equation that's given, notice the difference here between your ellipses and your hyperbolas is that they are separated with a minus sign, right? So you have a minus sign in the middle now. Because y is coming before x, we're looking at this equation and this information down here. I can tell that the center is at my origin because there's no y minus a number or y plus a number in parentheses in my numerators there. So the center is at the origin of 0, 0. So that means that h equals 0 and k equals 0. Then to find a, b, and c, we're going to use the information, well, right here I know that a squared is 1. So a equals 1. B squared is 4, so b equals 2. And then we're going to use the Pythagorean theorem here to find c. You see, and that should be an equal sign, not a plus sign at the end. So a squared is 1, b squared is 4, 1 plus 4 is 5. So the square root of, or c is the square root of 5. Okay, to find my vertices, I can have h, which is 0, and I can have k plus or minus a. So let's start with k plus a. 0 plus 1 is 1, or 0 minus 1 is negative 1. For my foci, I'm keeping h, and then I'm taking k and adding and subtracting off c, which is the square root of 5. So technically, my foci is 0, the square root of 5, and 0, negative square root of 5. And then the asymptotes, we're following this right here. You'll notice a lot of the time that we can just add k to this side, so we have y equals plus or minus a over b. So in this case, we have 1 over 2. And then we have x minus 0 plus 0. So really we're just left with y equals plus or minus 1/2 x for our asymptotes. And you can see the asymptotes drawn in here. Those are these dotted lines right here. Those are what the asymptotes I'm referring to. Okay. So the next one, we need to come up with an equation. And we have to complete the square for that. So we start by putting our x's next to each other and the y's next to each other. And then we add the constants over to the other side. Okay, so we have x squared plus 2x minus 9y squared minus 54y equals 80. Okay, and then you can complete the square. Well, half of 2 is 1, 1 squared is 1, so technically you add 1 to the other side. I do have to factor out a negative 9 before I can complete the square. Half of 6 is 3, 3 squared is 9. But don't forget, we're not adding 9 on the other side. We're taking 9 times negative 9, which is a negative 81. So when I add that all up, I get 0. Uh-oh. Usually we don't get 0. We want it to equal 1. So that may be a problem. I'm just going to kind of finish rewriting my completing the square here. And this is a problem. If it equals 0, that is what we call a degenerate hyperbola, and your lesson will go over your degenerate conics more in depth, but we never really want it to equal 0, and when that happens we say it's degenerate, and instead you have these two lines that are basically intersecting at your center, or where your center would be. So the center of that, after looking at completing the square, is -1, -3. Okay? So instead of having actual hyperbola, you just have two lines that intersect at that point. So, and the reason that we call it degenerate is because we cannot divide by 0. Right? So whenever that happens, it is a degenerate conic. Okay, let's look at an example where that does not happen though. So find an equation of the hyperbola with its center at the origin. Alright, so we know h is 0 and k is 0. Looking at the information, the y coordinates are what's changing. So coming down here, I want the y coordinates that are changing, so it's parallel to the y-axis. So I'm looking for information to fill into this formula right here. I know h and k, so I need to find a and b. Let's find a first. I know k is 0. So 0 plus a equals my vertices. If I'm adding, you think it'd be the larger of the two vertices, so a +2. So a is a +2. And to find c, we know k is 0. And c is referring to our foci, and for adding we want the positive value, so c is 4. To find b squared, we can use an alternate form of the Pythagorean theorem if we need to. Okay, so c squared is 16 minus 4 is 12, so this is b squared. And I come and plug in my information in now. So I have y minus 0, which is just y squared over 4 minus x squared over 12 equals 1. Okay, and then the last problem with my hyperbolas today is we're going to find an equation for the hyperbola. So looking at my vertices, looks like the and the foci, that the y value is staying constant there, so that means that k must be 0. To find h, we take half the distance, or the middle point, between my vertices. So the point between 2 and 6 is 4. So halfway between those would be my center, and the h would be 4. Okay. Now I can find a and c using this information. Since y is staying the same or constant, I'm using the parallel to the x-axis equation. Let's start with a. Now h is 4, so 4 plus a equals 6, because that should be the larger of the two if I'm adding. So to solve for a, that gives me 2. And I can kind of repeat that process with my foci. So h is 4. 4 plus c equals 8, because if we're adding, that should be the larger of the two values. So c equals 4. I can find b, or b squared, by taking c squared minus a squared. So 16 minus 4, again, is 12, like we had in the last problem. And to fill it in now, I think I have everything I need. You'd have x minus 4 squared over 4 minus y squared over 12 equals 1.